I'm Curt from Watsonville, California, and I came here to show you some interesting things we can build and make, and they all have to do with electricity and magnetism. So first, just let me show you this. If I put this battery here and connect it up, I get this amazing pattern, and I can change it. I can put my fingers here and make different patterns. I can move the tension and make different patterns. These are waves, standing waves. And if you see, there's one really basic wave that's oh no, that's two waves. Let me show you this. That's a half a wave. Half a wave. It's got a single maximum. If I cut it in the middle like this, now it's a whole wave. It's got two maximums. That's maximum of motion. When this one is up, this one is down. It's a crest and a trough and a node, a complete wave. And if I cut it here, then I got, oh, make it a little bit looser. Oh, how many is that? That's two waves, two complete waves. And if I cut it right here, I get three complete waves. A little more tension. Ah, how many is that? 1.5. 1.5 waves. But I didn't come here to talk to you about waves. Let's talk about these little motors. These are little motors run off of a battery. Just simple battery, simple motors. It's connected up. You could build this thing too. You don't even have to have the PVC. You can use sticks or cardboard, or you could build it on a chair, anything you want. Okay, so let me show you a few things you can do with these motors. It's called a DC motor because the battery is giving DC electricity, not like the wall, which gives you AC electricity. Okay, so basically the motor runs on the principles of electricity and magnetism, electromagnetics. Have you ever played with a magnet? Well, you should, because you can learn all kinds of things. Watch this. I'm gonna take two magnets. Well, first of all, actually, before I begin, you see I've got a lot of junk around here. All kinds of junk. I got tape, I got sticks and straws and cardboard and stuff. That's what you need. If you don't have a bunch of stuff, you maybe never be able to make anything. So you have to have a lot of stuff. You never know when you're going to need some specific piece to build something new. So be sure you have a lot of place. Maybe keep it in a little box, or a bigger box, or an even bigger box, and then maybe you need a cabinet, maybe you need a whole room to put the stuff in, because building things is very important. So anyway, I got a bunch of pieces of metal here. I've got aluminum, and I've got those little paper clips, and I think I've got in my pocket, I think I've got some money. I put the money there, and I'll see what attracts the magnet. Oh, not the aluminum. Oh, the money does. Okay, and how about the paper clips? Oh, yes, the paper clips also. You can try anything you want to see if it attracts the magnet. Okay, and then you could get another magnet too. And if you have two magnets, you realize, it's not just pulling. It pulls on that side, you flip it over, it's pushing now. Pulling and pushing. Wait a minute. With the coin, it's never pushing, only pulling. I think. You have to try this yourself. You should not believe me. I might be lying to you. You know, anything you see on the internet could be a lie. So don't trust me, okay? All right, so that's interesting. I think it's pushing and pulling on both, pulling on both sides and never pushing. All right, but I get two magnets. I can pull, I can push. Interesting. All right, so let me get a piece of string now. A piece of string, and I'll cut it off and I'll hang the magnet. Now the magnet will be free to move. Before I was holding it, but now it's free to move. Let's look at it. Spinning, stop it from spinning. Stop it from spinning. Oh, now it's going back and forth. Well, that's kind of interesting. to stop it from going back and forth, and it stays exactly in the same place. That's kind of interesting. If I take it like this, it doesn't like it. It's always going back and forth. If I wait long enough, it's going to stop. It's always going to be pointing that way. That's pretty strange. Let me get a little piece of tape. And I'll put the little piece of tape on the magnet. I'm going to put it in that direction. I'm going to put it on that side of the magnet. Okay, so I got the tape on that side. Okay, so now we got a black side and a white side to the magnet. I'm going to take that white side and turn it towards me. I'm in charge here. I'm controlling this magnet. I want the white side facing towards me. Actually, let me do it again. Put it right towards me. Oh, does not like it. Okay, no problem. I'll make it voice that way. Over there. Oh, it doesn't like it. This way. No, it doesn't like it. It's always pointing the same way. Do you know what direction that is? That's north. North. And this magnet knows that that's north. Even if I didn't know that was north, this magnet knows it's north. That's pretty weird. I wonder how the magnet knows it's north. Well, check this out. If I take this magnet underneath the table, I can move that one around. I'm going to take a bunch of magnets. I can move that magnet around, right? That means the magnetic force is going through the table. Okay? And if I put it up on top like this, and I put these magnets down here, now I can control it. Okay? I can make it point whatever way it wants, or whatever I want. Okay? But then I move this further away, it gets weaker and weaker. Can't really control it anymore. Move it down to here. Now it's pointing north again. But this magnet is actually still controlled by another magnet. A big magnet. A really big, like the biggest magnet you'll ever see, which is the planet Earth. Our planet Earth is also a magnet. And this magnet here is lining up with the planet Earth. That's pretty cool. That's very useful. If I was lost and there were clouds over the head and I couldn't see the stars, I couldn't see the sun, but I had this magnet, I would still know which way to go. I could use it. And actually, people did use it. For hundreds of years, people used this, it's called a compass. And they used a compass to find their way in the ocean, in the desert, in the forest. And they did that before they understood how it worked. Because it always works. You don't have to understand it. It just works. Okay? Let me back up a little bit. Is that not a little bit weird? I could control that thing. I could put a force on that thing without touching it. I'm not touching the magnet, but I'm putting a force on it. I'm moving that magnet without touching it. If I was going to move this table without touching it, like, I can't do it. But the magnets are doing it. They're not touching each other, but they're putting a force. That's called a force field. Force field. That means giving a force without contact. Force over a distance. That's a force field. And magnets do that. Gravity does that too. I don't know if you ever thought about that, but gravity pulls things down. Pulls things down every time it pulls it down. But it's not touching it. As soon as I let go of the coin, the Earth, our planet, is pulling it down, and then it touches it again. It's doing it with that, so that's a force field, a gravitational field. Okay? Very interesting. Okay, well, that's enough about magnets. Let me show you an electromagnet. You want to see an electromagnet? Okay. If you take a straw, and actually you don't need a straw, but it's more interesting with a straw. And then you take some of this wire. This is called magnet wire. And the magnet wire is super skinny, and it's got a paint. It's like varnish on the outside of it. And I take my straw and I wind it around the straw. Okay, I'm going to wind it up here. I want to leave a little bit at the end for another experiment. A bit more. The more you do, the stronger it will be. But that's enough. That's enough for now. Now cut that off, and now I have a coil of wire. Okay, that's a coil of wire, and this wire has that insulation, and I can take off that insulation with sandpaper. I don't have to have sandpaper. I could take it off with the scissors also. I could just sit here and scrape it off. And every time you scrape it off, you can see, because the color changes, you can see it coming off. It's easier and more complete if you do it with the sandpaper. Okay, so I'm going to strip that side just a little bit off of each side. You strip it like this, and then it's going to be possible to connect to the wire, because we want to connect to the wire inside the varnish, not the outside. I'm going to take this aluminum foil again. I'll take two little pieces of it like this, and I'm going to wrap them up, the two tips of the wire, so they have little mittens on the end of the pieces. Okay, and then it's going to be easier to connect it to the battery, because I'm going to get a little battery and I'm going to connect it on there. And I'm just going to grab it like this and like this. Now that's a complete circuit. Electricity is screaming around those wires and making a big current. So if I have something like this, like a little paper clip, and I open it up and I set it right here. I hope you can see this. We'll get a close-up. And then I put the electromagnet here, and the electromagnet's got a hole inside, right? It's a straw. And if I grab it just right, it's gonna do something amazing to that paper clip. Okay, you ready? Watch. Oh, it sucked it inside. Oh, no, look, 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 it's holding it inside. It's amazing, wow. Until I let go, and it falls out. That is known as a solenoid. Sucks, the electromagnet sucks things inside of it, because the magnetic field is the strongest inside there. Okay, so that's one thing you could do with an electromagnet. And then another thing is you can put a nail, put something big and made out of iron. You can put it in there and make it stay with some tape. All right, so you stick it in like this, and now it's stuck in there. So now I'm going to get all these paper clips over here, and I'm going to hook up my electromagnet again and see if I can pick them up. Oh, I got them. Look at that. Look at that. Oh, look at that. It's just like a real magnet, only it's better. It's better than a real magnet, because I can let go and they all fall off. You can turn it off. That's a real benefit. Because these permanent magnets, you can never turn them off. Once they're attracting, they continue to attract. So we got the electromagnet here, and it only goes when there's electricity going through it. You want to make it stronger? No problem. Make more coils, or put a bigger battery, and that'll make a stronger electromagnet. You can make an electromagnet that'll pick up a truck just with enough coils and enough electricity. Okay, well that's pretty cool, but how does the electromagnet push on the magnet? Well, what do we got here? We can hang, let me get this thing back over here. I'm just going to use this as a little place to hang something. I'm going to hang my magnet off of there. So now I got my, this is my compass, remember? It's just hanging there. But if I took my nail out, because the nail is going to attract to the magnet, right? But if I don't have a nail, this does not attract. Now I'm going to get it all the way at the end of the straw. I only want a very small amount of the straw sticking out from the coil. Okay? And then I'm going to hook it up again. We'll see if it can put a force on the magnet. So we've got electromagnet pushing on a permanent magnet. Okay, oh, look at that. Look at that. It's pulling on. That one's pulling on. It's pulling on the black side. Okay, now I'm going to turn it around. I'm going to put positive to negative, negative to positive. You know, batteries have two sides. One's positive, one's negative. So I'm going to flip it around so now the negative side is on the positive before, and let's check it out. Okay, now it's pushing. Now it's not pulling anymore, it's pushing. Whoa! But if I turn it around to the north side, to the side with the white tape, now it's pulling. Before it was pulling on the black side, now it's pulling on the white side. That just means it's a regular magnet. I forgot to show you that, but if this magnet, hold on, I put these two magnets together, and I'm going to put another piece of tape on that magnet, also on the north. Okay, and then I'm going to check it out. Do they like each other, the north and the south? How about they do? How about the south and the north? They do. But how about the north and the north? Oh, they don't like each other. They're pushing, repelling. And then how about the south and the south? No, they do not like each other. Okay, but one more time. With the coin, it likes the south, it likes the north. That, my friends, is the fundamental principle of magnets. Opposites attract, likes repel, and both sides attract things with iron. This thing must have some iron in it. It's actually two other elements, cobalt and nickel, but they don't pull as much. Mostly magnets pull on iron, and they always pull, they never push. Okay, so now you know fundamental principles of magnets. But once again, don't believe me. Get some magnets. You can find these things. These are not hard to find. You can just look around, find some magnets, try it yourself, prove to yourself that's the way it is. You may say, what does this have to do with these little motors? Or why is this important? Well, actually, it's extremely important because motors are made from electromagnets and permanent magnets. Every motor has got these kind of magnets inside. In fact, I'm going to show you. I'm going to get my nail here. I'm going to take apart one of these motors. By the way, you can find these motors too. You can look for them, buy them online or buy them at a store, but you can also find them in an old toy. If you have any kind of toy that moves, like a car or something that moves back and forth, it's going to have a motor in it. And you can wait till the toy is used a little bit and then rip it apart and take out the motor. Okay, because you can do a lot of things with that little motor. And you probably don't want to take it apart till maybe after it breaks. But I'm going to take this one apart because I know I can put it back together. I'm going to open up these two little ears. I'm going to pull the back off. Okay, and in the back, there's these little brushes. The little brushes are making contact with the main shaft there. And then you take at this and you see there's three little electromagnets right there inside the motor. Three little electromagnets connected to this little part that's connected to these brushes, that's connected to the two little ears that we're going to connect up to the battery. All right? So when you put this thing together, you've got electromagnets, and then you've also got magnets. Inside there, these black things, it's a magnet. Okay? So inside on two sides, there's two permanent magnets and three electromagnets. And as this thing turns around, those brushes, they make contact here and here and here, and they connect and disconnect, and connect and disconnect the different magnets, and they pull and push to make the thing turn. Does that make sense? I hope so. A little bit complicated, but you can see how it works. That was invented in 1821. 1821 was the first electric motor. Can you imagine everything we use electric motors for now? Pumps and fans and kitchen appliances and the starter on a car. That's all an electric motor. And none of that was possible before they invented these things. To invent these things, they had to make the connection first between electricity and magnetism. That happened in 1820. 1820, this guy, Ørsted, was giving a science demonstration, and he had stuff all over his desk. He was just demonstrating the interesting science things of the day. He was getting a little bit of money. He was a teacher, and he was making a little money on the side. So he had all this junk, and he was explaining some things, and he hooked up some electricity, and he saw a compass move. He hooked up the current of electricity, and the compass moved. And he didn't tell anybody. For like 3 months, he didn't tell anybody. But see, he's trying to figure out what's going on here. So finally, he figured it out, and he wrote a paper, and he published it. So now he's got the credit for finding that connection. And after that, the whole world started to understand that electricity and magnetism, they're really the same thing. And there's different ways to use them, including making motors. So I'm gonna make a couple of things with these little motors. But first, let me just show you. You could also make this really super simple motor. It's got these 2 pins, safety pins. It's got 2 magnets. It's got a battery. You just sit it there, and then, surprise, surprise, you make a little coil of wire. Just like the other one, only a little bit bigger. And then, the important thing is here, you scrape off the insulation on one side of the coil. Scrape it off. And you have to make this really nice and smooth. Make it beautiful. It's going to work better. So that it spins nicely. Like that. And then make sure this is all hooked up right and put it in. And then it starts to spin. Oh my gosh, it's amazing. It's a little motor. You can find out how to make these online. A lot of people are showing you how to make these. And now you know more or less how it works. It's the permanent magnet pushing on the electromagnet. A little bit complicated when the side comes around one way, there's still got the insulation and it's not making any connection, not making any current. Flips around the other way, it's got the current again. So it's only pushing or pulling half the time. That's what allows it to keep on going. Okay? All right, so I just want to show you that. And let me show you something else. That is this one. This one, it's got the same elements. It's got a coil of wire. Check that out. Coil of wire. And it's got a little fidget spinner. And underneath this fidget spinner are these 3 super powerful magnets. These are called neodymium magnets. They're 40 times more powerful than these little black ones. Okay, and they're coming over the top of this coil. Coil's got 1,000 winds on it. I didn't wind it myself, but my buddy said 1,000 winds. Okay, that could have taken a while, but it was necessary. It only works with that many winds. And then when I spin it, it's all connected up to this little LED light. And it comes on. There's no batteries. Check it out. No batteries at all. You hook it up and you've got electricity. Electricity's flowing. It's like free electricity. It's not connected to the wall, no batteries. Oh, wait a minute, actually, I had to spin it. I had to do the work there. I put the energy in. This is not free energy. I don't want to sit here and spin this all day long just to be able to have a little bit of light, okay? Well, what this is a generator. Actually making electricity. Making motion turn into electricity. The motor is exactly the opposite. The motor takes electricity and turns it into motion. Both of them are extremely important. The motor saves us all kinds of work. We just hook it up to some electricity and it does the work for us. The generator makes electricity. All we have to do is find some way to get something turning and we got electricity. All this electricity in your house, in the line here, basically all the electricity we use on a day-to-day basis that's not a battery is made from a generator. Because these wires are connected back through the system to a generator. It's a lot bigger than, it doesn't look like this. It's a huge, like a room full of a generator, and something is turning that generator. Could be the wind, could be water, could be steam. And they made the steam by burning something, coal or natural gas. Or it could have been a nuclear reaction that made a lot of heat and made the steam to turn a generator and give us this electricity. Well, electricity is pretty nice, it's pretty convenient, we use it all the time. But it's just the energy that came from whatever it was that made that generator turn. Okay, so we got motors, we got generators. This is electromagnetism. It's something that we should be happy we're living in this age after people figured out how to make this work. Right? 1821, first motor. Michael Faraday. Don't forget that name. That guy was a smart guy. Okay, so now I want to show you how to make, if you get one of these little motors, hobby motors they're called, you can make amazing things. Hundreds of things. I'll just show you a couple of things you can make, all right? You want some cardboard, and then you want a knife. Be careful with the knife, don't cut yourself with the knife. You don't even have to use a knife, you could just use scissors. And then I'm going to cut it off over here too. Oh, that's a really good knife. And then it's got these ugly staples, but that's okay, I'll leave the staples. I'm going to cut this off here, cut this off here. You always want some extra cardboard hanging around. And now I'm going to get this block of wood and I'm going to get this little stick. And I'm going to put the stick on the block of wood with my hot glue gun. Hot glue is quite useful. You should try to get a hold of one of these if you can. It's not necessary. You can always use tape, but hot glue is pretty convenient. So I'm going to put this here and I'm going to put the hot glue on the block, and the block is going to stick to the cardboard. Don't burn yourself with the hot glue. Don't touch that, it'll burn you. All right, don't touch the tip either. That's the hot part. You can touch this part over here, but right at the tip there, it'll probably burn you. I mean, you'll get over it, but it's not pleasant. Okay, so I'm going to put some on this little stick. Okay, put the stick right there. And then I'm going to put one of these motors right at the top of the stick. Okay, so I need more glue right at the top of the stick. Like I say, you don't need this glue. You can just use tape if you don't have the glue. And in fact, once I put the glue on, I'm going to reinforce it with the tape. The glue just got stuck, but I'm going to stick it through more with my little nail here. There it is. Now you want to be careful you don't get the glue down inside the motor. There's a little hole, a couple little holes there. Be careful, because that would just glue the motor shut, then it wouldn't turn anymore. Okay, look, I got it on my fingers, but I'm rubbing it off as fast as I can so it didn't burn me. All right, so now we got the motor on the top of the stick. Now I'm going to get some wire. You can use any wire you want. I got this little thin wire. You don't need very thick wire. Got the wire here. I'm going to get 2 pieces of the wire. And this wire has got thicker insulation. This is like normal wire. It's got like this plastic insulation, and the insulation needs to come off. But we can't take it off with the sandpaper. So you can use the knife to get it off, just like that. You can use the scissors to get it off. You have to be careful not to cut the wire inside. You get the scissors, just like that, and it comes off. Sometimes you can even use your fingernail, but eventually you want to get one of these, which is a wire stripper. This makes everything easier, and if you're going to be doing this more than a couple times, you got to have the right stuff. These things are not expensive, maybe 100 rupees. Okay, now you want to connect it up to the motor. Remember the two little ears I told you about? Just hook one to one ear, one to the other ear, and you're ready to go. Now you want to put something on top of the motor so you can see it spin. And a really good way to hook things onto the motor is to use the hot glue stick itself. You could cut a little piece off like that, and then you can just jam it on there, but sometimes you have to push too hard and it's painful or it breaks the motor. So if you have one of these little push pins, that's very nice. Just stick it right into the little piece of hot glue, and then it'll go on there very nicely right on the top like that. Beautiful. Now you can put anything you want on there. You can put another stick on there if I want. Let me glue another stick right on top of there. So now we got the stick. Okay, so now if it turns, we'll be able to see it. Okay, so now the last thing we need is a battery. All you need is one little battery, and it spins. Oh, wow. It's amazing. But it's not fast enough. I want it to spin faster. How am I going to make it spin faster? Another battery. I got two batteries. Let me show you how to make a little battery pack. If you've got a fancy battery pack like this, life is easy. You just put the batteries in. It's ready to go. But these things are not that easy to find. So let me show you how to make one without that. What you need is these two little pieces of aluminum foil, just like we used before. That makes everything connect up easier. Okay, two pieces of aluminum foil, and you fold them, you fold them, you fold them, you fold them again, and then that's on one side. And then again you fold it, and fold it, and fold it, fold it again, and that's for the other side. Okay, and then you get 4 pieces of tape. 1, 2, 3, 4. And you put one piece of aluminum foil on one of the batteries on one side. That was the negative side. And you put the other one on the other battery. That's the positive side. And then you put them together in the middle, like positive to negative, head to tail. Okay, does that make sense? Go positive, negative, positive, negative. So one side is going to be positive, the other side is going to be negative. Then you take the tape on the top and you just put them together. Make it nice and tight. If it doesn't work later, it's probably because the connections are bad. So you always want to try to make the connections as good as you can. Okay, there it is. There's your little battery pack. But you're not done. You want that thing super tight. So you take your tape again and you go over it like this. Wow! Stretching it down each side. If you have the black tape, electrical tape, it's even better. But you don't need it. That black tape is stretchy. It's made to stretch and hold things tight. The white tape works. Even clear tape will work. Okay, now we got 2 battery pack. Now one of these batteries, let's see, it says right here 1.5 volts. I think that's what it says. 1.5 volts. So you got 2, that'd be 3 volts. 3 volts, twice as much volts. Okay, let's try connecting it up. Oh, now we're talking. It's like a little fan, right? Here, let me put my face right over it. Oh, I don't feel anything. It's not blowing at all. What's going on? Well, actually, this thing is totally flat, right? Flat, 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 flat. But if you ever looked at a fan, of course you've looked at a fan. Any fan you've ever seen, and any propeller on an airplane or a helicopter, they're all tilted, twisted a little bit. So we need some way to make this thing tilt or twist. Actually, I'm going to use these two little pieces off of this box right here. And I saw they're almost exactly the right size. Now I'm going to glue them onto the front like this, or the top. I'll put one on this side. Okay, it's not working. Put this new piece of glue in. Technical difficulties. There it is. Okay. Put this one on one side. Oh, got some on my finger again. Getting this other one on the other side. Make it look like every fan you've ever seen. And then you're going to bend it a little bit because they're still flat, right? See that? See that? They're sticking off like that, but they're still flat. So then I'm going to bend it up a little bit. Wow, it's like that. You bend it up like this. Woohoo! Okay, wait till that glue dries. And it's ready to go. I'm going to hook it up again. Ah, now we're getting breeze. Nice breeze coming from this thing. Very nice. See how it's shaking? That means I didn't get it balanced very good. Oh, it's moving by itself. Oh, that's pretty cool. Okay. Now, if I want this thing to stay going, I could just twist these things around here, and I can put one of these paper clips onto the end of one of the wires. And then when I want it to stay going, I just put the paper clip onto the aluminum foil just like I would onto a piece of paper. I slide it on like this, like that, and it stays. There it is. You could take it home on the hottest days before the monsoon comes. You can blow on yourself nicely in your own room. And then you say, no, I want to blow harder. How are you going to blow harder? Another battery. You could put 2 or 3 or 4 or 5 batteries until the motor burns out. Then it won't work anymore. Okay, that's the first motor project. All right. Let me show you another one, which is another demonstration of the generator, the motor and the generator. I want to take this little motor, put it right here, and then I'm going to take another motor and I'll put it right here. And I'm going to hook these two motors together. So I'm going to have one as a motor and one as a generator. Okay? Watch this. Just glue them down there. Oh, actually, I'm going to glue one down, and before I glue the other one down, I'm going to connect them. It's a little bit difficult to connect them. You can just try to tape them together, but I found that it works better if you use string. So I'm going to put a string or a rubber band. You could use a rubber band too. And then I'm going to put, oh, by the way, you can sometimes find these, like these commercial ones you can buy that work really well too. But the point is, you don't need this. You could just make it yourself. Okay? So don't buy anything if you can avoid it. You can make everything just from junk. That's the goal. All right, so I'm going to get 2 more little pieces of this glue stick, and I'm going to hook them onto the motor shaft. Okay, I'll hook it with one. And I'm going to get another one. And I'm going to put those little holes in the bottom with the push pins and hook them onto the shafts here. Okay, so there's one. And here's another one. And then I'm going to put the string right across there. I think I'm going to try this to hot glue first, and then I'm going to tape it. Okay, we'll put some glue right there. Right on there, and then on this one also. So now we got the glue onto the string, and then I'm going to get the tape. So first, remember I was going to tape this one too, make this one stronger. Okay, now I'm going to tape these in the same way, but now it's on the glue stick. I'm going to make the tape a little bit skinnier. Just rip it sideways, a long way. It just grabs the one glue stick. Hopefully we get a close-up of this too. Okay, now I'm going to glue the other motor down like this. Now I'm going to see if it works. I'm going to connect the, well, first I got to put the wires on there. So I'll get 2 more wires. 1, 2. Strip them with my wire strippers. 1, 2, no, 2, 3, 4. Hook them on this side, only this side gets the electricity. 1. By the way, these tiny little ears that I'm hooking onto, they're very delicate. If you twist them too far, they'll come right off. You gotta be super gentle, super sensitive. Okay, now I'll get my battery pack over here and make sure that it works. It doesn't work. It's hitting the ground. I'm going to raise it up on another little piece of cardboard. You could probably put them up on a little piece of cardboard first instead of waiting till it didn't work. Okay, now, oh, it didn't dry yet. Gotta wait for the glue to dry. Not patient enough. Actually, the glue doesn't usually bond to the metal very well. The glue works better for plastic or wood or cardboard. Cardboard's falling apart too. Put some more glue on there. Okay, this time, oh wait, is it gonna, oh look at that, the cardboard's falling apart. I'll put a big old piece of tape on there. You should always be able to fix everything with tape and hot glue. I mean, not like your house or your electrical system or anything, but you know, anything like this. More tape, more hot glue, you can fix it. All right, here we go. And it's hitting the ground again. Wait, what's going on? It was working just a minute ago. I'm going to put some paper clips on there so it stays going when I hook it up. Now I can adjust it. Oh, maybe it's too tight. Yeah, it was too tight. Okay, now it's, oh, what happened? Bad connection again? Yeah, every time. It's a bad connection. Okay. Make sure the string is not too tight. Yeah, there it is. Okay, now it's cruising. Okay, so if everything I said was true, this motor is running this motor, so that means this motor is acting like a generator. Let's get a little light. I've got these little LED lights. I'm going to hook it up to this little motor right here and see if it's making electricity. And I hook it up just like this, and nothing happens. But I know these things only go in one direction, so I'm going to flip it around the other way and stick it in here, and still nothing happening. No problem, I'm going to get another one. I'll try this one. Okay, I'm going to hook this one up here, this one up here, and nothing yet. I flip it the other way, and let's see what I get, and I get nothing still. I think that means I need another battery. So I'm going to hook this on here just like this, and I'm going to get another battery. I got another battery. A battery right here. I've got this battery. This is also 1.5 volts. You can ask yourself, why is this one so fat and those ones are so skinny, and they're both 1.5 volts? Think about that. You can also think about if you put this in a toy or something, or radio, and you used it, how long would it last? Would the fat one last longer, or would the skinny one last longer? Ooh, listen to that. It's going much faster, but the light's still not going. Okay, remember, it only goes in one way. I don't know which way it goes yet. So I'm going to turn it around the other way. And okay, here it goes. Is it going? Still not going. What's going on? Look, look, look. It's supposed to be going. Nothing's happening. What do you think? Should we add another battery? I've never seen this fail. Hey, let's hook up this motor. Instead of the battery, let's hook up this other motor. Because it's a generator, right? It should be making electricity. Well, if we hook one motor up to the other motor, it should make a generator. It should be making electricity. Go put it right through the little ears. Okay, got three batteries, and oh, did you see that? Oh, it's barely moving. Oh, that's pretty pathetic. That's totally unimpressive. Oh, this one just fell off. Okay, go, 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 go. Go, 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 go. Okay, well, let me work on this. I'll get back to you on what's going on here, okay? So, look, we found the problem. The motor, the little motor, we thought maybe it wasn't producing enough electricity, so we put a bigger motor in. And then we decided to check how much current, how much voltage it's creating. So we got the motor, we got the electric meter. So now we've got it, and the meter is set on DC volts, and you can hook it up there. Go ahead and hook it up and see how much voltage we've got coming out. And it's only 0.3 volts. Look at that, 0.3 volts. Well, let's check how much voltage is going in. Come over on this side. Okay, now we'll check the voltage coming in. The voltage from the batteries coming into the motor. Ah, it's only wow, it's only 0.9. Well, that means these batteries are really dead now. Okay, let's take the motor off and now check the batteries. How much from end to end, what do we got there? Okay. 4.8, less than 5. They're dying fast. We're putting too much burden on these poor little batteries. Oh well, we gave it our best shot, but you could see that was generating a little bit of electricity using the motor as a generator. All right, I hope you had a good time playing with me and my motors and electricity and magnetism. So many interesting things you can make with these little motors. I hope you can go out and find some and make all kinds of things. I made one more thing. I made, instead of the propeller, I just put a weight, offset weight. So it's swinging around and it's not balanced. My cardboard is really weak. I'm going to put another piece of tape on that cardboard. It's always good to use the best stuff you got, even if it's junk. And now I'm going to hook it up and see what happens. Oh, it goes moving across the table. It's like a little pet. Come here, come to mom. Oh, it came off there. But you can see how many different things you could make with the little motors and batteries. And don't forget, it's all based on magnets and electromagnets. That's what's making the motion from the electricity. Okay, go out there and make some cool stuff. Don't let anybody get in your way. And if you want to learn something, go learn it. Don't wait for somebody to teach you. Just go figure it out yourself. Have a good time.